Welcome. The BoreCore archive is a collection of slow, methodical recordings of technical processes and perfectly boring routines designed to help you relax and fall asleep. New procedures are added regularly, so don't forget to like and subscribe. Time to relax, close your eyes, and take it on down to Sleepy Town.
Welcome. You are an airfield operations specialist. You work at an airport. Specifically, you work on the airfield, which is the part of the airport that contains the runways, taxiways, aprons, and all of the surfaces, lights, signs, and markings that allow aircraft to arrive, depart, and move between arriving and departing. The airfield is distinct from the terminal, where passengers wait. Passengers do not come to the airfield. The airfield is where the work is. Your primary responsibility tonight is the runway inspection. A runway inspection is a systematic examination of the runway surface, its associated lighting and markings, the runway safety areas, and the immediately surrounding airfield environment, conducted at regular intervals to identify any condition that could pose a hazard to aircraft operations. You will conduct this inspection in a vehicle, slowly, in the dark, with a spotlight, while communicating with the air traffic control tower on a dedicated radio frequency. You will do this multiple times tonight. You will do it tomorrow night. You will do it the night after that. Runway inspections are required by the Federal Aviation Administration, which in the United States is the regulatory authority for civil aviation, and are codified in FAA Advisory Circular 155-20-018, Airport Safety Self-Inspection, as well as in each airport's Airport Certification Manual, which is the document the airport maintains to demonstrate its compliance with FAA regulations and to establish its specific procedures for all safety-related operations. Your airport has one of these manuals. It is lengthy. The runway inspection section is thorough. You have read it. You follow it. The runway inspection is also called an airfield inspection, a self-inspection, or simply a check, depending on your airport's terminology and your colleagues' preferences. Whatever it is called, it is the same thing, a methodical, documented look at every surface on which aircraft operate, at intervals frequent enough to catch hazards before they become incidents. An incident in aviation is a specific term. It means an occurrence other than an accident associated with the operation of an aircraft that affects or could affect the safety of operations. A piece of metal debris on a runway that is ingested by a jet engine is an incident, or it is an accident, depending on the outcome. The distinction between incident and accident in aviation is a matter of what happened next. A runway inspection that finds the piece of metal before the aircraft does means nothing happened next. This is the preferred outcome. The preferred outcome is always nothing happening next. Your shift begins at 10 o'clock in the evening. The airport is a large commercial airport serving domestic and some international flights, with 2 parallel runways and an intersecting crosswind runway. plus the associated taxiway system, cargo aprons, general aviation ramp, and fuel farm. The last scheduled departures of the evening will complete around midnight. After that, through approximately 5 in the morning, the airport will operate at reduced, but not zero activity. Cargo flights, a small number of late arrivals, charter operations, and maintenance activity. Aircraft do not stop using runways at night. Runways, consequently, do not stop needing inspection at night. Let us begin. You arrive at the Airfield Operations Center. The Operations Center is where your shift begins and ends. It contains the duty desk, the radio communications equipment, the Airport Operations Vehicle Dispatch Area, the NOTAMS terminal, the weather display, and the wall-mounted airfield diagram that you have looked at so many times. It requires no conscious effort to read. The Operations Center smells like old coffee and radio equipment. This is a universal constant. You sign in for your shift. You review the shift log from the previous team. You are looking for any open maintenance items on the airfield that affect inspection routes or require follow-up, any NOTAMs issued by or affecting your airport, any wildlife activity that was noted, any special operations planned for tonight, such as cargo carrier activity, military flights, or emergency exercises, and the status of any airfield lighting or equipment that was reported as malfunctioning. NOTAM stands for Notice to Air Missions, formerly Notice to Airmen, revised in 2021. A NOTAM is a notice distributed to personnel concerned with flight operations, informing them of information essential to flight safety. NOTAMs can be issued for many things: a runway temporarily closed for maintenance, a taxiway light outage, a displaced threshold, a construction zone on the airfield. When you are on the airfield conducting your inspection, you are not just aware of the current physical state of the airfield. You are also aware of the NOTAMs, because the pilots flying into and out of your airport have been briefed on those NOTAMs, and what the pilots expect to find on your airfield should match what is actually on your airfield. If a NOTAM says runway 17 left is clear and available, runway 17 left must be clear and available. You are one of the mechanisms by which this is ensured. You check the weather. The current conditions at your airport are clear skies, visibility 10 miles, wind from 270 at 8 knots, temperature 52 degrees Fahrenheit, dew point 41 degrees Fahrenheit. The difference between the temperature and the dew point is 11 degrees, which means frost formation is not an imminent concern tonight. Frost forms when surface temperatures fall to the dew point. When the dew point is close to the air temperature, moisture in the air condenses onto cold surfaces. A surface temperature of 32 degrees Fahrenheit or below, combined with a temperature dew point spread of 3 degrees or less, is a frost advisory condition. Tonight, the spread is 11 degrees and the temperature is above freezing. You note the weather and move on. You will continue to monitor it throughout the night because weather changes and the airfield changes with it. You check the inspection vehicle. The airport operations vehicle assigned to your shift is a white pickup truck with an amber light bar on the roof, an airfield radio mounted on the dash, a spotlight mounted at the driver's door, and markings on the exterior identifying it as an airport operations vehicle. You walk around the vehicle before driving it onto the airfield. This is called a pre-operational inspection, and it is not optional. You check the tires. All 4 tires are properly inflated and free of visible damage. You check the lights, headlights, tail lights, brake lights, the amber light bar, all functional. You check the radio. You verify that it is tuned to the appropriate ground control frequency and that you can transmit and receive clearly. You check the spotlight. It works. You check the fuel level. There is sufficient fuel for the night's operations. A vehicle that runs out of fuel on an active runway is not a good outcome. You have sufficient fuel. You gather your inspection materials. These include the Airfield Inspection Form, which is either a paper form on a clipboard or an electronic form on a tablet, depending on your airport system. The form has fields for every element of the airfield that must be checked during each inspection, organized by area. You will complete this form during and immediately after the inspection. The completed form becomes a record. The record is retained. If something is later discovered to have been missed or misreported, the record is evidence. You complete it accurately. You also carry a flashlight with fresh batteries, a reflective safety vest, a set of traffic cones for marking any hazard you may find that requires immediate marking before the maintenance crew can respond, and the airport's emergency response plan quick reference card, which is laminated to a size that fits in your shirt pocket and which specifies the radio frequencies, contact numbers, and initial response protocols for the range of incidents that can occur on an airfield. You know these protocols. The card is for the moment when you are in the middle of an incident and you want to confirm quickly and without relying on memory alone that you are doing the right thing in the right order. You contact the air traffic control tower on the operations radio frequency. You identify yourself, your vehicle number, and your intention to conduct the scheduled airfield inspection. The controller acknowledges you, provides you with any relevant information about current or anticipated traffic, and clears you to enter the movement area when you are ready. The movement area is the part of the airport that aircraft use, the runways and taxiways. You cannot enter the movement area without permission from the tower. This rule exists because aircraft and vehicles on the same surface at the same time, without coordination, is one of the ways runway incursions happen. Runway incursions are one of the most serious categories of aviation safety event. You maintain constant radio contact with the tower throughout your time in the movement area. The radio is always on. You are always listening. This is not a requirement you find burdensome. It is the natural condition of being on an airfield at night. You drive to the vehicle access gate at the perimeter of the movement area. This gate is equipped with a keypad or card reader that requires authorization to open. Access to the movement area is controlled. Not everyone at the airport has access to the movement area. Access is granted based on training, certification, and operational need. You have all three. Before you open the gate, you do two things. First, you activate your amber light bar. The amber light bar is the primary visual signal to aircraft and other vehicles on the airfield that you are a vehicle operating in or near the movement area. Amber is the designated color for airfield vehicles. Aircraft pilots in the pattern on approach or taxiing are trained to look for and expect amber lights. You do not drive onto the airfield without the amber light bar operating. This is not a suggestion. This is the rule. The light bar is on. Second, you look. You look left, and you look right, and you look up. Looking up is not a gesture. Looking up is checking for aircraft on final approach to the runway nearest your access gate. An aircraft on a 3-degree glide slope at a standard approach speed may cover significant ground in the time it takes to recognize a problem and stop a vehicle. You look. There is nothing on approach. The sky is dark and clear and empty in the relevant direction. You open the gate. You drive through and stop. You close the gate behind you. The gate must be closed. An open gate in the perimeter fence of the movement area is a security vulnerability and an operational hazard. The gate is closed. You confirm this visually in your mirror. It is closed. You are now on the airfield. The airfield at night, viewed from a slowly moving vehicle on the perimeter taxiway, is a particular kind of landscape. It is very flat and very large and very lit in specific places and completely dark in others. The runway edge lights define the runway boundaries in 2 parallel lines of white lights extending away from you into the distance. The threshold lights, where the runway begins for landing aircraft, are green on the approach end and red on the departure end. The taxiway edge lights are blue, which is the universal color designation for taxiway lighting. The runway centerline lights, embedded flush in the pavement surface, are white for most of the runway and alternate red and white in the last 3,000 feet before the departure end, and solid red in the last 1,000 feet. These colors tell pilots exactly where they are on the runway. If you are driving on the runway, they tell you the same thing. You know them. You do not need to think about them to read them. You read them the way you read a road you have driven every day for years, which is accurately and without conscious effort. You drive to the starting point for your inspection route. Your airport has a standardized inspection route documented in the Airport Certification Manual, designed to cover every required element of the airfield in a logical, efficient sequence. You follow this route. Deviating from the route without a reason is how things get missed. You follow the route. Your first inspection is of runway 17 left. Runway designations are based on magnetic heading, rounded to the nearest 10 degrees, with the last 0 dropped. Runway 17 has a magnetic heading of approximately 170 degrees, which is roughly south. The parallel runway to its right, from a pilot's perspective on approach from the north, is designated 17 right. You are beginning with 17 left. The opposite end of the same runway, approached from the south, is designated 35 left, because 350 degrees is the reciprocal heading of 170 degrees. A runway has two numbers, one for each direction of use. One physical strip of pavement, two designations. Runway 17 left is 10,000 feet long and 150 feet wide. 10,000 feet is approximately 1.9 miles. You will drive its entire length twice, once along one side and once along the other, plus the center line. This will take time. You have the time. You contact the tower. You request permission to enter runway 17 left at the threshold for inspection. The controller advises that there is one aircraft, a regional jet, on a 12-mile final for runway 17 left with an estimated arrival in approximately 9 minutes. The controller tells you to hold short of the runway. You acknowledge. You hold short. Holding short means stopping your vehicle at the holding position marking. A double yellow solid line with a double yellow dashed line painted across the taxiway at the point where the taxiway meets the runway safety area. You do not cross this line without clearance. The aircraft on final has priority. You wait. You watch the aircraft come in. At 12 miles out in clear conditions, it is a white light, barely distinguishable from the stars. As the minutes pass, it becomes two lights, the landing light and the navigation lights. Then it resolves into a shape, a silhouette against the slightly lighter sky, gear down, stabilized on approach. It crosses the threshold of runway 17 left and touches down approximately 1,000 feet past the threshold in the touchdown zone, which is the first 3,000 feet of the runway, marked with a series of white rectangular bars on each side of the center line. The aircraft decelerates. The thrust reversers deploy, audible even from where you are holding, a rising then falling mechanical roar that is one of the definitive sounds of a large airport at night. The aircraft slows to taxi speed and turns off the runway at the third high-speed exit. The runway is clear. The controller clears you onto the runway. You acknowledge the clearance, read back the runway designation as required, and drive onto runway 17 left. You begin your inspection at the threshold end, the south end, designated 35 left from this direction. You drive slowly. Your speed on the runway during inspection is between 15 and 25 miles per hour. This is slow enough to observe the pavement surface and all associated elements in detail, and fast enough to complete the inspection in a reasonable time between aircraft operations. You activate the spotlight and direct it ahead and to the sides. The first element you inspect at the threshold is the threshold markings. The threshold markings are the white stripes, 8 of them on a runway of this width, painted across the runway at the beginning of the landing area. They are painted in a specific pattern defined by FAA standards. Each stripe is 150 feet long and 10 feet wide, with 10-foot gaps between stripes, and with a specific offset from the runway edge. You examine the threshold markings as you drive over them. They are visible, white, and unobscured. There is no rubber contamination on the threshold markings, which can occur if aircraft are touching down short of the intended touchdown zone. Rubber contamination makes white markings dark. Dark markings are harder for pilots to see. Tonight, the threshold markings are white. You examine the threshold lights. The threshold lights are the green lights that mark the beginning of the landing area for approaching aircraft. They are installed in a row across the full width of the runway at the threshold. You count the lights that are illuminated. All threshold lights are illuminated. You note this. A threshold light outage is a reportable condition and requires a NOTAM. Tonight, there are no outages. You begin driving down the runway. The surface extends ahead of you, lit by your headlights and spotlight. A river of gray pavement between the two white lines of edge lights. You watch the surface. The primary purpose of a runway inspection, in terms of immediate safety, is the detection and removal of foreign object debris. Foreign object debris is abbreviated FOD in aviation. FOD refers to any object found in an inappropriate location on the airfield that could damage aircraft or injure personnel. The term is also used as a verb. To FOD, a runway means to inspect it for foreign objects. You are FODing the runway. This is a legitimate sentence in your profession. FOD can be many things. It can be a bolt or a screw dropped by a maintenance crew. It can be a piece of tire rubber shed by an aircraft during landing. It can be a rock or piece of gravel displaced from the runway edge onto the pavement surface. It can be a piece of aircraft skin panel that's separated during takeoff. It can be a bird, deceased, that is not technically debris, but is treated the same way during an inspection. It can be a tool. It can be a section of runway light cover lens that is cracked and displaced. It can be a plastic bag blown onto the runway by wind. It can be a bone if your airport is near a wildlife area. It has, at various airports, been all of these things and others not listed here. The consequences of FOD depend on what the FOD is and what part of an aircraft encounters it. A small bolt ingested into a jet engine at takeoff power causes damage ranging from a compressor blade nick, which is repairable, to catastrophic engine failure, which is significantly more than repairable. A piece of tire rubber on the runway surface is by itself not dangerous to an aircraft. The aircraft sheds tire rubber during every landing, and the rubber itself poses little risk. But the same piece of rubber, if encountered at high speed on takeoff, can behave aerodynamically in ways that direct it toward an engine intake. The debris does not need to be large to cause damage. It needs only to be in the wrong place at the wrong time, which is what all debris is, by definition. Air France Flight 4590, which crashed on takeoff from Charles de Gaulle Airport in Paris in July of the year 2000, is the most cited example of FOD-related catastrophe. The aircraft, a Concorde, ran over a titanium wear strip that had fallen from a Continental Airlines DC-10 that had departed minutes earlier. The strip ruptured a tire, which shed debris that ruptured a fuel tank, which caused a fire, which led to the aircraft's destruction. 113 people died. The piece of metal that initiated this sequence of events was 435 millimeters long and weighed approximately 306 grams. It was on the runway because a previous aircraft had lost it. It was on the runway because no one had found it yet. You drive slowly. You watch the pavement surface in the spread of your headlights and spotlight. You watch from edge to edge. In the dark, with the lights set up correctly, debris on the runway surface casts a small shadow that is often more visible than the object itself. A bolt lying flat on the pavement is visible primarily as a small dark irregularity in the otherwise uniform gray surface. You have trained your eyes to look for irregularities. You look. At approximately 3,000 feet from the threshold, your spotlight catches a reflection. You slow further. You approach. It is a section of runway light insert lens, a clear plastic cover approximately 6 centimeters in diameter that has cracked and partially displaced from its housing in the runway centerline light fixture. The fixture itself is flush with the pavement, designed to be run over by aircraft without damage to the aircraft. The cracked lens, however, has a raised edge that is no longer flush. You stop. You note the location. Runway 17 left, centerline, approximately 3,000 feet from the 35 end. Centerline light, fixture number 41. You mark the location with a cone. The cone is orange, weighted at the base, and clearly visible to aircraft and vehicles. Placing a cone on a runway requires coordination with the tower. You contact the tower and advise of the debris find and the cone placement. The controller acknowledges and notes the location. You photograph the fixture with your phone for documentation. You collect the displaced lens fragment and place it in the debris bag you keep in the vehicle for this purpose. The raised fixture housing itself will require maintenance attention. You will report it. Until it is repaired and cleared, it is a noted condition. You note it on your inspection form. Time, location, description of defect, action taken. Cone placed. Maintenance notification required. NOTAM consideration. You will discuss with your supervisor whether the condition warrants a NOTAM. A flush-mounted light fixture with a displaced lens cover and a slightly raised edge in the centerline of an active runway is a marginal condition. It does not require immediate runway closure, but it must be assessed by maintenance and cleared before the next operational period. You have found it. You have documented it. You have marked it. This is the inspection working correctly. You continue down the runway. The remaining centerline is clean. You reach the far end, the 35 threshold, and you turn to inspect the departure end lights, the runway end identifier lights, and the blast pad. The blast pad, also called the stopway or overrun area, is the paved area beyond the runway end, not suitable for normal aircraft operations. but providing a surface for aircraft that overrun the runway to decelerate on rather than immediately encountering unpaved terrain. You examine the blast pad. It is clear. The yellow chevron markings that identify the blast pad as a non-operational surface are visible and intact. There is no debris. You turn and begin the return pass along the opposite side of the runway. You drive the length of the runway again, this time along the right edge, watching the pavement on the right half of the runway surface and the right edge lights and edge markings. Pavement condition is a separate but related inspection concern from FOD. While FOD is something on the runway surface, pavement condition refers to the condition of the runway surface itself. The pavement can fail in several ways, each of which has a different cause, appearance, and urgency. Cracking is the most common form of pavement distress. Runways are made of either asphalt concrete or Portland cement concrete, and both crack over time under the combined stress of aircraft loads, thermal expansion and contraction, water infiltration, and ground movement. Cracks are classified by their type and severity. A hairline crack is a thin crack with no displacement or spalling at the edges, and is typically a low-priority maintenance item. A working crack is a crack that has widened, displaced, or developed loose material at its edges, and is higher priority. A map crack, also called alligator cracking, is a network of interconnected cracks forming a pattern that resembles the skin of an alligator and indicates structural failure of the pavement base, which is a significant concern. You look for cracks during every inspection. You log their location and classify them as best you can from a moving vehicle. Your maintenance team will conduct detailed pavement condition surveys on a scheduled basis, but your nightly inspection provides a continuous baseline that allows rapid detection of new or worsening conditions. Spalling is the breaking away of small pieces of pavement material from the surface. On concrete runways, spalling often occurs at the edges of pavement joints, the saw-cut or formed joints that divide the concrete into slabs and allow for thermal movement. Joint spalling produces loose concrete fragments, which are, by definition, FOD. When you find spalling during an inspection, you are simultaneously recording a pavement condition deficiency and a potential FOD condition. Both are noted. Rutting is a depression in the pavement surface, typically in asphalt, caused by repeated loading in the same area. Runways experience the highest loading in the touchdown zone, where aircraft wheels contact the surface at significant weight and speed, and in the areas near the runway centerline where aircraft tires track. A rut in the runway surface can cause aircraft tire damage, affect aircraft directional control during takeoff and landing, and trap water that can contribute to hydroplaning. Rutting is measured in depth, typically in fractions of an inch, and assessed against FAA standards for acceptable runway surface deformation. Rubber contamination, briefly mentioned earlier, warrants more attention here. When aircraft tires contact a runway surface at landing speed, a small amount of rubber is deposited on the pavement. Over many landings, this rubber accumulates in the touchdown zone as a dark, glossy deposit that reduces the surface friction of the runway. Reduced runway friction means reduced braking effectiveness for landing aircraft. This is a safety concern, quantified as a friction coefficient. The friction coefficient is the ratio of the braking force to the normal force, a dimensionless number between 0 and 1, where 1 is theoretical maximum friction, and 0 is a perfectly frictionless surface. An acceptable runway friction coefficient for commercial operations is typically above 0.5. When rubber contamination reduces friction below the minimum acceptable level, the runway requires rubber removal treatment, a process using high-pressure water or chemical cleaning agents to remove the deposited rubber and restore the pavement surface texture. You observe rubber contamination in the touchdown zone of runway 17 left. The surface in the first 2,000 feet past the threshold is noticeably darker than the surrounding pavement. This is not new. It was noted on previous inspections and is being monitored. The friction level is currently within acceptable limits per the last friction survey conducted 3 weeks ago. Friction surveys are performed using specialized vehicles equipped with instruments that measure the friction coefficient at operational speeds while driving the runway surface. They are not performed during routine nightly inspections. You note the rubber contamination, its approximate extent, and that it is unchanged from the prior inspection. The maintenance and operations teams will schedule rubber removal based on the friction survey data and the observed contamination level. You note a small crack, approximately 3 feet long, running diagonally across the right half of the runway at approximately 7,000 feet from the 3.5 threshold. You stop. You examine it with the flashlight. The crack is approximately 2 millimeters wide at its widest point, with no vertical displacement at the edges, no loose material, and no branching. This is a low-severity longitudinal crack. You note its location and dimensions on the inspection form. You photograph it. It is not a condition requiring immediate action, but it is now documented. The next friction survey will include a physical assessment of the crack. If it has widened or developed loose material by the next inspection, the classification will be upgraded. Complete the return pass of runway 17 left. The runway has yielded 1 centerline light defect requiring maintenance, 1 crack documented for monitoring, and the ongoing rubber contamination in the touchdown zone. These are not unusual findings. They are the routine findings of a runway that is used by aircraft several hundred times per day and is subject to the weather, the load, and the time. Runways do not stay in perfect condition. They are maintained toward acceptable condition. The inspection is how you know where they are on that spectrum. You drive the runway a 3rd time, this time focused specifically on the lighting system. A runway lighting system is more complex than it appears from the air or from a photograph. What looks, from an arriving aircraft's perspective, like two parallel lines of white lights, is in fact a system of multiple distinct light types, each serving a specific navigational or advisory function, each maintained to specific intensity and color standards, each connected to an electrical system that allows the air traffic controller to adjust the brightness remotely, and each subject to failure in ways that must be detected and reported. The runway edge lights are white from the threshold to within 2,000 feet of the far end, where they transition to yellow, indicating to a pilot that they are approaching the end of the usable runway. This color transition exists on every instrument runway. If you observe a yellow light where white is expected, or a white light where yellow is expected, this is a maintenance finding. The runway centerline lights are embedded in the pavement in a row down the exact center of the runway, spaced 50 feet apart. They are white from the threshold to within 3,000 feet of the departure end, then alternate red and white from 3,000 to 1,000 feet from the end, then solid red for the final 1,000 feet. A pilot who sees red and white centerline lights knows they have 3,000 feet of runway remaining. A pilot who sees solid red centerline lights knows they have 1,000 feet remaining. These are not decorative color choices. They are information delivered through light at a moment when there may not be time for any other form of communication. You drive the centerline slowly, straddling the centerline lights to observe them without driving directly over them. Each light has a lens cover that is flush with the pavement and designed to be run over, but routine vehicle traffic over the lights accelerates wear. You observe each light. At the 6,000-foot mark, 2 consecutive centerline lights are not illuminated. You note the outage. Runway 17 left centerline lights at approximately 6,000 feet from the 35 threshold. 2 consecutive fixtures unlit. 2 consecutive centerline light outages in any segment of the runway constitute a NOTAM condition per FAA standards. You note the requirement to issue a NOTAM and contact the tower. You contact the tower and advise of the centerline light outage and the location. The controller acknowledges and notes it. Your supervisor will need to be contacted to initiate the NOTAM through the airport's NOTAM office. You make a note on your inspection form. The outage does not require immediate runway closure, as the runway remains within FAA standards for minimum lighting requirements. But the NOTAM must be issued before the next operational period to ensure that pilots are informed. You continue your lighting inspection. The runway threshold identification lights, also called RTILS, are 2 flashing white lights installed on each side of the runway just before the threshold. They flash simultaneously at a rate of approximately 40 to 50 flashes per minute and are visible at a significantly greater distance than the threshold lights themselves, helping pilots identify the runway environment in reduced visibility conditions. You observe the RTILS as you reach the threshold. Both are flashing. Both are white they are functioning correctly. The approach lighting system extends beyond the runway threshold into the area beyond the airport boundary to guide aircraft from instrument flight down to visual flight during approaches in low visibility. Your inspection does not typically cover the full extent of the approach lighting system, which extends 1,000 to 3,000 feet beyond the threshold, depending on the system type. But you inspect the inner portion of the approach light structure from the threshold area. The approach lights for runway 17 left are a medium intensity approach lighting system with runway alignment indicator lights, abbreviated MALSER. The inner bar of the approach lighting system, the portion closest to the threshold, is inspected visually. All lights are illuminated. No lights are dark or damaged. The Precision Approach Path Indicator, called PAPI, is a system of 4 light units installed on the left side of the runway at the threshold, angled to show pilots whether they are on the correct glide slope for approach. The PAPI works by showing a combination of white and red lights depending on the aircraft's vertical position relative to the glide slope. All 4 lights white means the aircraft is too high. All 4 lights red means the aircraft is dangerously low. 2 white and 2 red means the aircraft is on the correct glide slope. 1 white and 3 red means slightly low. The PAPI system is one of the most important visual aids in the approach environment. You verify that all 4 PAPI light units are illuminated and operating. You observe the color sequence from a low angle to confirm that the white-red transition is occurring at approximately the correct angle. It is. The PAPI is functioning. You complete your lighting inspection of runway 17 left. Findings: 2 unlit centerline lights at 6,000 feet requiring a NOTAM. All other lighting systems functional. You have 1 maintenance item and 1 NOTAM action from this runway. You document both. You proceed to runway 17 right. Runway 17 right is the parallel runway. It is also 10,000 feet long and 150 feet wide. It serves primarily departing aircraft during evening operations, with arriving aircraft using 17 left, though the configuration changes based on wind, traffic, and operational needs. You request and receive clearance from the tower to enter runway 17 right for inspection. The tower advises of 1 departure holding on the taxiway awaiting clearance. You have a window of approximately 12 minutes before the departure will be released. You acknowledge, enter the runway, and proceed. You drive 17 right at the same methodical pace. The surface is in somewhat better condition than 17 left, which is typical. Runways that receive higher arrival traffic accumulate rubber contamination and thermal stress from brake applications faster than runways used primarily for departures. Departing aircraft accelerate on the runway, which subjects the surface to a different kind of stress than the landing loads of arriving aircraft. But the touchdown zone degradation pattern is absent. You find no FOD On the initial pass of 17 right, the surface is clear. The pavement shows hairline cracking in the central portion, consistent with previous inspections, unchanged. No new cracks are apparent. You complete the first pass and begin the second. On the second pass, along the right edge, you observe that a runway edge light at approximately 4,000 feet from the 35 right threshold is emitting a noticeably dimmer light than the adjacent fixtures. Runway edge lights can dim due to lens contamination, voltage fluctuation, or a failing lamp element approaching the end of its service life. A single dim light is a maintenance finding, but not a NOTAM condition unless it is dark. This one is lit, but visibly dimmer than its neighbors. You note it. Light number identified by its location from the threshold. It will be assessed by the electrical maintenance team. You observe the holding position markings as you approach the intersection of 17 right with the crosswind runway. The holding position marking is the double solid and double dashed yellow lines that indicate where a vehicle or aircraft must hold unless cleared to proceed onto the runway. At intersecting runways, the holding position marking for each runway must be clearly visible and in good condition, because the consequence of an aircraft or vehicle misidentifying or failing to see the marking and proceeding without clearance is a runway incursion. You examine the markings. They are clearly visible, white and yellow paint on pavement, unmarked by rubber deposits or pavement damage. You note them as satisfactory. You complete 17 right. The runway is clear of FOD. The pavement shows existing conditions unchanged. One dim edge light noted for maintenance. Lighting otherwise functional. You document all of this and proceed to the crosswind runway. The crosswind runway at your airport is designated Runway 09 and Runway 27 for east and west operations, respectively. It is shorter than the parallel runways at 7,500 feet and is used primarily when wind conditions make operations on the parallel runways unfavorable, when one of the parallel runways is closed for maintenance, or for general aviation and smaller aircraft operations. Tonight, the crosswind runway is not in active use. It is, however, still inspected. An inactive runway is not an uninspected runway. You request clearance from the tower to inspect Runway 0927. The controller clears you to enter, advises that the runway is not in use, and asks you to advise when you've completed the inspection and exited. You acknowledge and proceed. The crosswind runway is darker than the parallel runways. When a runway is not in active use, the controller may reduce the lighting intensity or switch certain supplementary lighting off. The runway edge lights are at a lower intensity setting. Your spotlight is more important here. You enter the runway at the 27 threshold and drive east towards 09. The surface is clean. The crosswind runway sees significantly less traffic than the parallel runways, and its pavement condition reflects this. Less rubber contamination in the touchdown zones, less wear on the edge markings, slightly better overall surface texture. This is the pavement's reward for being used less often. The lights, however, have the same failure modes as any other lights. They do not care about traffic volume. At approximately 2,000 feet from the 09 threshold, you find FOD it is a bird. Specifically, it appears to be a Canada goose, adult, deceased, lying on the left half of the runway approximately 30 feet left of the center line. It is intact. It has not been struck by an aircraft. It is, as best you can determine from the vehicle with a spotlight, a bird that died on a runway, which is a thing that happens because runways are, from a bird's perspective, a large flat open area, and large flat open areas are where birds land. You stop. You confirm with the spotlight that the bird is deceased and not simply injured or stunned. It is not moving. You retrieve a disposal bag from the vehicle supply kit. You put on gloves. You remove the bird from the runway surface and place it in the bag. This is wildlife removal, which is a routine part of airfield operations. Birds on runways are a concern not only as FOD, but as indicators of wildlife activity in the airfield environment. A single bird on a runway is an event. Multiple birds or recurring wildlife presence in a particular area is a wildlife hazard pattern requiring coordinated response from the airport's wildlife biologist or wildlife management contractor. You note the bird removal on your inspection form. Species identified as Canada goose, approximate location, condition, disposition. You will report it to your supervisor and to the airport's wildlife management log. The wildlife log tracks species, location, frequency, and disposition for all wildlife encounters on the airfield. This data informs the airport's wildlife hazard management plan, a required document under FAA regulations that assesses and manages the risk posed by wildlife to aircraft operations. You are contributing to this document tonight by writing down that you found a goose. You complete the inspection of the crosswind runway. No additional FOD, no significant pavement defects. The lighting is functional at the reduced intensity setting. The runway is clear and serviceable. You advise the tower of your inspection completion and exit the runway. After completing the runway inspections, you inspect the taxiway system. Taxiways are the paved surfaces that connect runways to aprons, gates, hangars, and other airport facilities, allowing aircraft to move between the runway and the terminal area without using the runway itself. This is important because an aircraft moving slowly from its gate to the runway threshold is vulnerable, large, and not going anywhere quickly. Taxiways allow this movement to happen in a controlled, separated environment. The efficiency of an airport's taxiway system directly affects the throughput of the runways, and the safety of the taxiway system directly affects the safety of every aircraft transition between the gate and the runway. Taxiways are distinguished from runways by their lighting and markings. Taxiway edge lights are blue, as noted earlier. Taxiway centerline lights are green, embedded in the pavement in the same manner as runway centerline lights. Taxiway markings are yellow, as opposed to the white markings on runways. This color distinction is deliberate and consistent across every civil airport in the United States. Yellow means taxiway, white means runway. A pilot who crosses a yellow line when they expected a white line, or vice versa, is in the wrong place. These color standards make the wrong place situation easier to detect. You drive the primary taxiway routes serving the parallel runways. The parallel taxiways running the length of each runway, the connector taxiways linking them to the terminal aprons, and the taxiways serving the cargo and general aviation areas. Your inspection covers the pavement surface, lighting, signage, and markings of each taxiway segment. Taxiway signage is a significant inspection element. Airfield signs come in two types: mandatory instruction signs, which have white text on a red background, and information signs, which have black text on a yellow background or yellow text on a black background. Mandatory instruction signs include runway designation signs at holding positions, designating which runway the holding position protects, and NOE signs, indicating that an aircraft must stop. These signs must be illuminated, legible, and correctly positioned. A sign that is dark, damaged, or obscured by vegetation or debris is a hazard. You examine each sign as you pass it. On Taxiway Alpha, the main parallel taxiway for runway 17 left, you find a taxiway centerline light that is flickering. Flickering indicates either a loose connection or a lamp at the end of its service life. You note the location. Flickering lights are higher priority than simply dim lights because they can be distracting, and because the flickering typically precedes complete failure. A dark taxiway centerline light in a critical location, such as on a low visibility route or near a runway entry point, is a NOTAM condition. You will report this to maintenance and your supervisor to assess the priority of repair. On Taxiway Bravo, the parallel taxiway for 17 right, you observe that a section of blue edge lights on the west side of the taxiway between the B3 and B4 connector taxiway entries has 3 consecutive lights that are unlit. 3 consecutive taxiway edge lights unlit in a segment are a more significant finding than a single outage. You note the location precisely and will include this in the maintenance dispatch notification. You observe the runway guard lights at each runway entry taxiway. Runway guard lights are pairs of alternating flash yellow lights installed on each side of the taxiway at runway holding positions, providing an additional visual warning that an aircraft or vehicle is approaching a runway. They alternate in a specific pattern: left, right, at a rate designed for maximum conspicuity. You verify that all runway guard lights at runway entries are operational. All are functioning. This is a satisfying finding. Runway guard lights are among the most important lights in the prevention of runway incursions, and having all of them working is the correct state of affairs. You complete the taxiway inspection. You have found a flickering centerline light on taxiway Alpha, 3 unlit edge lights on taxiway Bravo, no pavement defects requiring immediate action, all mandatory signs illuminated and legible, all runway guard lights operational. All findings are documented on the inspection form. You proceed to the apron areas. The apron, also called the ramp, is the area where aircraft park to load passengers and cargo, receive fuel, and be serviced. The apron is generally not a movement area in the same regulatory sense as runways and taxiways, because aircraft on the apron are under the direction of ground handlers and airlines rather than air traffic control. However, the apron connects to the taxiway system, and the boundary between the apron and the movement area must be clearly defined and respected. Your inspection of the apron focuses on conditions that could affect aircraft safety during apron operations, or could result in debris migrating from the apron onto the taxiway or runway system. FOD on the apron is a persistent concern. Ground support equipment, maintenance activities, catering operations, baggage handling, and fueling all occur on the apron, and all generate potential FOD. Ground crews conduct their own FOD walks on the apron, but you inspect the apron perimeter and the transition zones between the apron and the taxiway system. You drive the apron edge road, the vehicle lane that runs along the outer boundary of the apron near the taxiway system. You observe the condition of the blast fences, the structural barriers that separate jet engine, exhaust from the taxiway when aircraft push back from the gate. Blast fences are periodically damaged by the forces they are designed to absorb and by vehicle contacts. Damaged blast fence sections are a structural maintenance item and are noted. You observe the apron lighting. The apron is lit by elevated floodlights mounted on poles throughout the ramp area. All floodlights are illuminated. The apron is adequately lit for the overnight ground operations that are still underway. A cargo carrier is loading at the east freight apron, with ground crew visible under the floodlights, moving cargo containers on tugs. This is normal activity. You observe them briefly, not because there is anything to observe, but because situational awareness on the airfield means knowing who is where. You note the activity in your shift log. You check the fuel farm perimeter. The fuel farm is the area where aviation fuel is stored in large above-ground tanks before being distributed via underground hydrant systems or fueling trucks to aircraft. The fuel farm perimeter is fenced and is not directly accessible during your inspection, but you drive the perimeter road and observe the fence condition, the signage, and the surrounding area for any evidence of fuel spills or drainage issues that might indicate a leak. The perimeter is intact. There is no visible evidence of fuel spill. You note the perimeter check as satisfactory. You inspect the drainage structures along the edge of the movement area. Runways and taxiways are graded to channel water off the pavement surface and into drainage inlets, preventing water accumulation on the runway surface that could cause hydroplaning. Drainage inlets can become blocked with debris, particularly after wind events that deposit vegetation and litter. A blocked inlet does not cause immediate failure, but standing water on runway surfaces is a safety concern, and the drainage system is inspected to ensure it is functioning. Tonight, the drainage inlets on the south end of the field are clear. You note them as satisfactory. After the initial full field inspection, you return to the operations center. You compile your findings. You initiate the maintenance notifications for the centerline light defect on 17 left, the 2 unlit centerline lights requiring a NOTAM, the dim edge light on 17 right, the flickering centerline light on taxiway alpha, and the 3 unlit edge lights on taxiway Bravo. Each notification goes to the airfield maintenance supervisor on call with the location, the nature of the defect, and the priority level. The maintenance team will assess and respond based on the priority of each item. You contact the NOTAM office or your designated supervisor to initiate the NOTAM for the 2 unlit centerline lights on runway 17 left at 6,000 feet. The NOTAM is issued through the FAA NOTAM system and will be visible to flight crews and dispatchers planning operations to and from your airport. The NOTAM describes the condition precisely. Runway 17 left, 2 unlit centerline lights at approximately 6,000 feet from the 35 left threshold. This information is now available to every pilot who requests NOTAMs for your airport. The condition is disclosed. The system is working. You also initiate the wildlife log entry for the Canada goose. The log entry requires date, time, species, number of animals, location on airfield, what aircraft were operating at the time, if any, and disposition. The goose was removed. No aircraft were on the runway at the time of discovery. The entry is complete. The time is 2:15 in the morning. The airport is in its quietest period. The last scheduled arrival completed 40 minutes ago. The cargo operation on the east apron is still active. Occasional aircraft movements on the taxiway, cargo aircraft, a private jet that arrived late, a repositioning aircraft from a regional carrier. The tower is staffed, but quiet. The radio carries only routine transmissions. You will conduct your next inspection at 3 a.m. This is the scheduled interval for your airport during the overnight low traffic period. During peak operational hours, inspections are conducted every 30 minutes or after every significant weather event, or when a specific concern warrants an immediate check. At 2 in the morning, with minimal traffic and no weather concerns, the 3-hour interval is appropriate. This does not mean nothing happens between inspections. It means that the risk level is managed by the interval chosen, and the interval is chosen based on the risk level. These things are calibrated against each other continuously. You complete your paperwork at the duty desk. The inspection forms are filed in the daily inspection log. The maintenance notifications are logged in the maintenance tracking system. You make a note in the shift log of all findings, actions, and notifications. The shift log is a running narrative of the night's events, written in the neutral, factual tone of all operational documentation. It does not express opinions. It records facts, times, and actions. Future readers of the shift log, whether they are reviewing it tomorrow morning for routine handoff purposes or examining it years from now in the context of an investigation of something that happened tonight, will find a clear, accurate record of what was observed and what was done about it. You write it with this in mind. You pour a cup of coffee. It is your second cup of the night. You drink it at the duty desk, watching the airfield through the operations center window. The runway edge lights are visible from here, two converging lines of white and yellow that disappear into the dark. The PAPI lights on the threshold of 17 left are red in your direction, which is correct. You are not on the glide slope. No one should be on the glide slope right now. No one is. At 3 a.m., you conduct the second full field inspection. The inspection follows the same route as the first. The findings are: the maintenance crew has already replaced the two unlit centerline lights on 17 left. Both are now illuminated and working. You note this: defect cleared. The NOTAM remains in effect until you verify the repair and formally close the defect, at which point the NOTAM will be cancelled. You verify the lights. They are working. You contact your supervisor, who contacts the NOTAM office. The NOTAM is cancelled. The runway is returned to normal status in all systems. This is the cycle: inspect, find, report, repair, verify, clear. It is a closed loop. You are part of every segment of it. The flickering centerline light on taxiway Alpha has been replaced by the maintenance crew as well. It is now steady and white. You note the repair. The three unlit edge lights on taxiway Bravo have not yet been repaired. The maintenance crew assessed them and found a junction box fault that requires a part not available until the morning. A NOTAM for the taxiway Bravo edge light outage has been issued. Ground crews operating on taxiway Bravo overnight are aware of the condition. The area is operationally acceptable because the outage is in a non-critical segment of the taxiway with adequate remaining lighting. But it is documented, NOTAM'd, and scheduled for repair at first opportunity. The second inspection yields no new findings. No FOD, no new pavement defects. No additional lighting outages. The airfield is in the condition documented from the first inspection, minus the items that have been repaired. You document the second inspection on a new form. All findings, none new, prior defects, as noted, partially cleared. You file the form. You conduct the third inspection at 4:30 a.m. The third inspection is always the quietest of the night in terms of findings, because the airfield has been inspected twice in the previous 4 hours, and any significant new defects that developed during that time would be unusual. What the third inspection does, consistently, is confirm the airfield is in the condition last documented. Nothing has changed. This confirmation is its own value. Absence of new findings is not absence of information. It is the information that the airfield is stable, that the lighting is functioning, that the surfaces are clear. You find nothing on the third inspection. No FOD, no new defects. The pavement is as it was. The lighting is as repaired. The taxiway Bravo condition is unchanged. The crosswind runway is clear. You drive the perimeter taxiway and observe the approach lighting structures from the boundary road. All illuminated. You return to the operations center. You document the third inspection. The airfield is ready for the morning push. On mornings, when weather conditions have produced precipitation, dew, or frost overnight, you conduct a runway friction test before releasing the runways for the morning's first flight operations. Tonight, conditions were clear and dry. A friction test is not required this morning. We will describe the process as it would occur because it is a reasonable thing to know, and because the description is long. A runway friction test is performed using a specialized vehicle called a continuous friction measuring equipment vehicle, or CFME. The CFME is a vehicle equipped with a fifth wheel, an instrumented wheel mounted between the axles that maintains contact with the runway surface at a controlled slip ratio, meaning the wheel is partially braked while the vehicle is moving, simulating braking conditions. The instrumented wheel is connected to sensors that measure the forces on the wheel, from which the friction coefficient is calculated continuously as the vehicle moves down the runway. The CFME vehicle drives the runway at a standardized test speed, typically 40 miles per hour for most testing protocols, and records friction coefficient values at fixed intervals, typically every 100 feet. The resulting data produces a friction profile of the entire runway, a graph showing the friction coefficient at every point along the runway's length. Low friction areas, such as the touchdown zone with rubber contamination, or a section of pavement affected by water, ice, or other contamination, appear as depressions in the friction profile. The friction coefficient values are assessed against minimum acceptable friction levels established by FAA Advisory Circular 155.3.7010, which specifies the maintenance friction level, the design objective friction level, and the minimum friction level for each runway surface type. Runways with friction coefficients below the minimum friction level require immediate action, which may include applying sand or chemical deicer to restore friction on a temporary basis, or scheduling grooming or rubber removal to restore the pavement surface. Runway grooves are one of the primary pavement design features for managing wet weather friction. Most commercial runways are grooved. The pavement surface is cut with with transverse grooves, channels running perpendicular to the runway centerline, spaced a specific distance apart, that allow water to drain laterally off the runway surface when an aircraft tire rolls over it. Without grooves, the tire compresses water ahead of it as it rolls, generating a water pressure wave that can lift the tire off the surface, a condition called hydroplaning. With grooves, the water has somewhere to go, into the grooves and off the side of the runway. Grooved runways resist hydroplaning. The grooves wear over time and are recut as needed. A contaminant report is required when runway surfaces are contaminated with water, snow, slush, ice, or frost. The contaminant report specifies the type of contaminant, its depth or thickness, the percentage of the runway surface area affected, and the braking action in plain language terms. Good, good to medium, medium, medium to poor, poor, or nil. Nil braking action means the runway is essentially frictionless, which is an aircraft performance emergency. You will not file a nil braking action report lightly. You will not file it at all tonight because the runways are dry. But you know what it means and when it would be required. The morning shift begins arriving at the operations center at 5:45 a.m. The day shift supervisor and the day shift operations specialists come in, pour coffee, and review the overnight shift log. You walk them through the night's findings and the status of each open maintenance item. The centerline light defect on 17 left, cleared, verified, NOTAM canceled. The 3 unlit edge lights on taxiway Bravo, maintenance scheduled for this morning, NOTAM still active. The dim edge light on 17 right, reported, scheduled for assessment. The flickering centerline light on taxiway Alpha, repaired and cleared. The Canada Goose, removed, logged. The cracked centerline light, lens on 17 left at 3,000 feet. Repair scheduled, cone removed. Fixture is flush and will be re-inspected before the morning push. The day shift supervisor nods at each item. These are normal items. Not every night produces normal items. On nights, when a significant weather event has occurred, when a bird strike has been reported by a flight crew, and FOD debris from the strike may be on the runway, when a gear problem has been declared by an arriving aircraft, or when a vehicle has struck a piece of airfield infrastructure, the morning handoff is less routine. Tonight was routine. You appreciate the nights that are routine in the specific way that you appreciate any system working as it should, which is quietly and without event. You conduct the final inspection of the night before the first morning departure. This inspection is called the pre-ops inspection, and it covers all runways and primary taxiways before the morning rush begins. The purpose is to confirm that the airfield is in acceptable condition for operations after the overnight period, to verify that all open maintenance items are either cleared or appropriately marked and NOTAM'd, and to detect any new conditions that developed during the final hours of the night. You enter the movement area for the last time this shift. The sky is beginning to lighten in the east. The runway edge lights are still bright against the dawn sky, but they have competition now from the natural light that is beginning to fill in the darker areas of the airfield. You drive runway 17 left. The surface is clear. The centerline lights are all functioning, including the 2 that were repaired during the night. The pavement is dry. The markings are visible. The lights are working. You drive runway 17 right. It is also clear, dry, and fully lit. The dim edge light has not yet been replaced, as that repair was scheduled for this morning. It is still dim but illuminated. Its location is noted. You drive the crosswind runway. Clear. You drive the taxiways. Taxiway Alpha is clear and fully lit. Taxiway Bravo has the 3 unlit edge lights as before, with the NOTAM in effect. All other taxiway conditions are normal. The runway guard lights are all functioning. The mandatory signs are all illuminated. You exit the movement area and return to the operations center. You contact the tower and advise that the pre-ops inspection is complete and the airfield is acceptable for morning operations, with the 1 open NOTAM for taxiway Bravo noted. The controller acknowledges. At 6:22 a.m., the first departure of the morning, a narrow-body jet operating a flight to a hub city calls ground control for taxi clearance. The controller issues clearance. The aircraft begins to move. It taxis from the gate, through the terminal apron, onto taxiway Alpha, down the parallel taxiway, and holds short of runway 17 left at the holding position where you checked the markings last night. The controller clears it onto the runway. The aircraft lines up. The engines increase to takeoff thrust, and it accelerates down the runway you inspected 3 times in the past 8 hours. It rotates at approximately 1,500 feet past the threshold and climbs away to the south. The runway that aircraft just used is the runway you drove in the dark at 11 p.m. The centerline lights it used to maintain its direction during the takeoff roll include the 2 that the maintenance crew repaired at 2 in the morning because you found them dark and reported them. These are facts. They are not dramatic facts. They are the normal facts of an airfield that operates correctly because the people who are supposed to inspect it do inspect it. And the people who are supposed to fix it do fix it. And the systems work in the ordinary, reliable, undramatic way they are designed to work. You complete your shift log. You note the pre-ops inspection result, the first departure, and the time of your shift end. You sign the log. The log is filed. Before you leave, the paperwork, airport self-inspection documentation, is a regulatory requirement under Title 14 of the Code of Federal Regulations, Part 139, which governs the certification of airports that serve scheduled air carrier operations. Part 139 requires airports to conduct self-inspections and to maintain records of those inspections. The records must include the date and time of each inspection, the name of the person conducting the inspection, the conditions observed, and any corrective actions taken. These records must be retained for a minimum of 12 months. Your completed inspection forms for tonight's 3 inspections, plus the pre-ops inspection, are 4 documents. Each has the date, time, your name, and the condition of every element of the airfield you inspected, plus notation of every defect found, every maintenance notification sent, every NOTAM initiated or canceled, and every wildlife event. These 4 documents will be filed in the airfield self-inspection log binder or uploaded to the airport's electronic operations management system, depending on your airport's method. The inspection records do several things. They provide real-time operational data for the maintenance team, what needs to be fixed and where. They provide historical data for the airport's pavement management program, where defects are recurring, which areas are degrading faster than expected, whether maintenance interventions are achieving the desired results. They provide legal and regulatory documentation that the airport is conducting required inspections. They provide, in the event of an accident or incident involving runway conditions, a contemporaneous record of the runway's state at the time of the most recent inspection before the event. This last function is the one that no one wants to use. The records are maintained anyway. You also complete your wildlife log entries for the night. The goose is logged. The wildlife management coordinator will review the log in the morning. If patterns emerge, they initiate additional wildlife mitigation measures, habitat modification, harassment techniques such as pyrotechnics or audio deterrence, coordination with USDA Wildlife Services for more intensive management. The data you collect tonight contributes to this process, even when it is a single goose on a crosswind runway at midnight. The single data point is part of the pattern. You review the NOTAM status before departing. The taxiway Bravo NOTAM is active and will remain so until the lights are repaired and verified this morning. All other NOTAMs from your shift have been canceled. The active NOTAM is correctly reflected in the airport's NOTAM record. Pilots planning operations this morning will see it. The disclosure is complete. The maintenance team has begun their morning work. The technician assigned to taxiway Bravo has already driven out to the junction box to assess the repair. You see the maintenance truck on the taxiway from the operations center window, amber light bar flashing. They will have the lights back on before the morning rush reaches its peak. You know this not because you have verified it, but because this is what the maintenance team does, which is fix things. You have completed an overnight runway inspection shift. During this shift, you conducted 4 separate airfield inspections, covering 3 runways with a combined length of approximately 27,500 feet, a taxiway system comprising several miles of paved surface, the apron areas, and the associated lighting, signage, drainage, and safety areas. You found and documented 7 discrete defects. You removed FOD from 2 locations, including 1 deceased bird. You initiated 2 NOTAMs. You canceled 1 NOTAM after verifying its clearance. You logged 1 wildlife event. You filed 4 inspection forms. You drank 2 cups of coffee. Nothing happened to any aircraft tonight as a result of a condition on the airfield. You do not know whether anything would have happened if you had not inspected. You will never know this. The value of preventive inspection is measured in the absence of outcomes, which is a difficult thing to measure and an easy thing to undervalue. It is, however, the correct way to value it. You drove slowly in the dark next to airplanes. You looked at the ground. You wrote things down. You called the maintenance team. You drove slowly in the dark next to airplanes again. This is what you did for 8 hours. The first aircraft of the morning is a small dot climbing to the south. Navigation lights blinking. Already above the approach path, it flew down 12 hours ago. It is en route to somewhere. The runway it departed from is ready for the next one. You made it that way. Good night, or good morning. You are going home. It is morning. The runway lights are beginning to fade against the rising sky. In a few minutes, the controller will reduce the light intensity from step 5 to step 3 because the sun is coming up and the full intensity is no longer needed. The runways are still there. The lights are still on. The surface is clear. It will need to be inspected again this afternoon.